Welcome, everyone. This is Bruce Kinsey with the Pacific Northwest National Laboratory and Director of the U.S. Department of Energy's Municipal Solid-State Street Lighting Consortium. Welcome to today's webinar, Lessons Learned from Outdoor Connected Lighting System Installations, brought to you by DOE's Better Buildings Challenge. Like other webinars we've conducted, this is intended to provide some increased depth on a topic that you've been hearing about, likely from vendors and others, and you'd like to know more about it from an objective source. We'll hopefully answer many of the questions you may have during the presentation, but if not, you'll have an opportunity to get them answered directly at the end. I'll have a bit more to say about that in a moment, but before we get started, I want to hand the mic over to Crystal MacDonald of the U.S. Department of Energy's Office of Energy Efficiency and Renewable Energy to say a few words of introduction. Crystal?
Very well, thank you, Bruce. Good day, everyone. I do lead the Outdoor Lighting Accelerator, which sits on the Better Buildings platform, and we engage municipalities that are working on updating outdoor lighting projects to high performance outdoor lighting, and that includes street and roadway lighting and exterior lighting in parks and recreation, et cetera, et cetera. So we've been doing pretty good work, I would say, over the past year and a half or so, and we have about another year to go with our accelerator efforts. And I am pleased to say that we currently have 3 states, 5 regional energy networks, and 15 cities. We now have 23 partners in total, with an addition of the city of Chicago. I'd like to welcome the city and look forward to gaining and sharing Chicago's experience to help advance other municipal outdoor lighting conversions. We're pulling together resources from all of our partners that are captured in a tool like our Outdoor Lighting Decision Tree tool that's available on the Better Building Solutions Center website. We're getting very close to meeting the President's challenge of committing at least 1.5 million outdoor lights to high-performance upgrades. We're now at about 1.3 million, so we're looking to work with more municipalities and increase project estimates to get us across that 1.5 million finish line. So in this effort, every poll counts. The commitment we gained via the Outdoor Lighting Accelerator will also count towards the Global Lighting Challenge announced by Secretary Moniz at the 21st session of the Conference of the Parties in Paris last month. And finally, I encourage you to register for the DOE Better Buildings Summit. This year's summit will be held May 9th through the 11th, 2016 in Washington, D.C. at the Washington Hilton Hotel, and more information can be found on our website regarding that. We do intend to have a cohort meetup, technical assistance office hours, along with other external and internal lighting sessions during the summit. Once again, thank you for your attendance today, and I'll now turn the mic back over to Bruce. Thank you.
So today's webinar is focused on what we are used to calling street lighting controls. Much of the community has now adopted the phrase connected lighting rather than lighting controls to reflect all the additional capabilities that are going to be enabled with the implementation of these systems. These systems are essentially becoming citywide networks with nodes at each street light that will happen to offer monitoring and control of those street lights as just one of potentially many features. I don't want to steal any thunder from our speaker today, but while control of the street lights can offer an immediate value proposition, we believe that the additional capabilities are ultimately what's going to drive the implementation of these systems as part of the current movement towards smart cities and Internet of Things and whatever else you want to call it. So I think we're all wise to be learning as much as we can about these systems now while we're still just in the initial stages of what's a forthcoming sea change. Okay, so let's get started. Our speaker, Michael Poplowski, came to work on our solid-state lighting team about 6 years ago, following 12 years in the commercial semiconductor industry. He's become increasingly involved in the connected lighting arena and largely organized the first of DOE's workshops on this topic last November, and a very successful meeting that was too. And in fact, if you're interested, following this webinar, you can find the presentations from that meeting posted on DOE's solid-state lighting website. And for that matter, our second connected lighting workshop is scheduled for this June. I don't think registration is open for that yet, but you can sign up to be kept updated on that meeting, or just monitor the site yourself for when that link becomes available. The homepage there is at SSL for solid state lighting, ssl.energy.gov. So back to the topic at hand. Michael really knows his stuff, so don't be shy about throwing your questions at him. Again, you can submit these at any time using the questions pane on your computer. We have about 40 minutes scheduled for his presentation, and then perhaps up to a half hour or so for Q&A is needed. So I think we've got plenty of time, and we can always end early if needed. So without further ado, let me turn this over to Michael.
Okay, so we're going to be talking again mostly about lessons learned from existing installations or pilot projects, right? Lessons learned by talking to municipalities or utilities, maybe engaging with them during their project or pilot, or actually directly supporting them. So more on what's been done thus far and less on kind of what the future might hold and where people are at, again, in terms of leveraging the capability of this technology towards smart cities and whatnot. So here's just a brief outline of the slides I'm going to go through and the topics. This presentation is very much based on a presentation we gave at Strategies in Light last year, in case anybody was there. So we'll do a little introduction on what is a networked outdoor lighting control system and who is interested in them and why thus far. Not comprehensive, of course, but just a sampling of, again, some of the more prominent installations in the United States and at least what drove them. And then we'll talk a bit about kind of one of the key value propositions that are at least getting people to consider connected lighting systems. So both maintenance improvements and in particular energy savings, additional energy savings enabled by adaptive lighting, which if you want to convert them into financial savings require consideration of utility tariffs. And so we'll talk a little bit about that and the related item for many people, many municipalities in particular today, around lighting system ownership. Then we'll go over kind of a few, again, not comprehensive, of the maybe issues or things to think about that have been uncovered in some of these early installations around installation startup and commissioning and how that relates to various features and capabilities amongst the different offerings in this technology area. And then I'll say just a few words about some future possibilities and challenges. So to start here, we loosely said, this is about connected lighting. So this is technology that allows you to network your outdoor lighting system and to both control and pull information back remotely from that system, right? So at a high level, at a block diagram level, most technology solutions available today kind of fit the diagram shown here, right, where you're going to install some device in the field onto your streetlights that maybe enables you to control their output and collect other information. You may install other types of devices that could become part of that network, such as meters or various sensors. And then typically, not for every system, but for most systems, information going to and from those field devices goes through what is often, not always, called a gateway, or it could be a router or some other, some people use other phrasing. But again, this is basically an interface between the devices and the field and a bigger, broader, often but not always public network infrastructure. So again, this doesn't cover every possibility. Some systems don't require a gateway, and there are various technical implementations of the network. You see kind of two extremes just shown in the diagram here. Some networks in the field are formed using a star configuration, where every device talks directly to a gateway. Other networks are formed with what is called a mesh configuration, where devices kind of broadcast their information, and it goes to their nearest neighbor and is relayed. So every or many of the devices are both are relays, if you will, or receivers and repeaters. And in fact, many systems out there actually behave in some kind of hybrid way between the star and a mesh, but just kind of a good idea to understand the broad differences there. And again, a gateway often is necessary to bridge, if you will, or connect the field device network with a broader network. It could be connect through Ethernet to the internet, for example, or a privately owned network, or wirelessly, perhaps via the cellular network, again, to the internet or a privately owned network. And once communication is enabled to that broader network infrastructure, well, any computing device could, through that same infrastructure, communicate with and potentially manage the field devices, right? And the other piece of equipment and technology that completes a system is often referred to as a central management system, set of software installed often on a server, although it could literally run on a single desktop PC. So it's software, usually tying into, again, a local or remote database and providing access to one or more workstations that, again, allow for the configuration, control, the scheduling, programming, and collection and of data from the network devices or from the devices out in the field. So hopefully you get a feel for, from that diagram and brief description, that systems are more complicated than devices, right? So when you look at outdoor lighting control past, right, most outdoor lighting systems in the United States are controlled, but they're controlled by a single device, right, attached, one per streetlight. And that is literally a component, you know, that becomes part of the streetlight. And there's a little bit of consideration in terms of how you select and install that. But here we're talking about a much more sophisticated system. And the process that I think we've seen that's required to really correctly figure out what you need and specify and create requirements and solicit and deploy and eventually own and operate these types of systems really demands some additional thought and consideration. So this slide is attempting to kind of, at a high level again, show some steps, right, that one, some delineation between some stages, if you will, of a deployment that we find most people end up having to go through, whether they initially consider them or not. And under each, if you will, category are some specific additional considerations, right? So at the beginning, often what's required is to really take a hard, often, you know, maybe a first time in a long time look at acknowledging what is the status of your existing infrastructure, right? What are your data acquisition existing capabilities out in the field? But really, as highlighted in red, what are your needs and goals? Why might you install this technology? And then you're going to want to, you know, think about establishing requirements. Maybe that's a detailed specification. Maybe that's a less detailed communication of problems that you want solved, and or business opportunities or partnership models that you're open to, right? Because more and more people are approaching the deployment of this technology from a variety of strategies, if you will, rather than a traditional procurement and transfer of ownership, if you will. And then solution design and selection. Sometimes, but not always, this might include the specification of a specific technology, but more often what makes more sense is, again, to focus on performance needs, problems that you want solved. In some cases, there might be some modeling or scenario analysis that you might want to do it as a user if you can, or consult with someone to do, or one or more technology providers might be willing to do for you. Deployment is a multi-stage, needs to be thought about, I think, as a multi-stage process. It's not just install something and turn it on and it runs. We like to think of this in multiple phases, if you will, that I refer to as installation, startup, and commissioning. I'll go into a little more detail on what I mean by those words in another slide or two. And finally, operation and management. Once again, acknowledging that this technology in practice, but frankly in terms of leveraging its full capability is not something that you again just deploy and turn on and let it run. You're going to want to leverage its ability to report back on how it's performing, analyze that feedback, maybe challenge some of your initial assumptions, make changes, improve the performance over time. And then again, in addition, some of the core features and capabilities involve offering data that might help improve maintenance services, and more, the ability to measure things out in the real world. Initially, maybe streetlight characteristics, but more and more other variables, other environmental conditions, etc. And that data enables other value propositions and creates other things to think about. So here I'm just going to briefly review again some of the major installations that we've been aware of in the United States. These could be installations that are by and large completed or in process, and just say a few words about maybe not the only, but one of, if not the main value proposition that drove the installation, right? So many people, I think, are aware of Los Angeles's leadership position and willingness to really test technology as soon as it's available. That was certainly true for LED, and they were one of the earliest adopters and installers of lighting control systems also. And they predominantly did this to get a better handle on their maintenance needs, right? Especially when they were going out early with as yet unproven in those numbers LED technology. So they installed a good portion of their initial LEDs together with the Acuity Roam system. And maybe if you follow some of the press, they are currently transitioning their control solution to a system or a technology offered by Philips. San Jose, also in California, another early adopter of this technology, but for very different purposes, right? They were interested in taking advantage of the adaptive lighting capability, right? And adjusting light output over the course of the night to both save energy and potentially address environmental needs, given the presence of an observatory, a very high-profile observatory, in the San Jose area. And to date, they've installed the outlet system. Glendale, Arizona, another early adopter that installed the Acuity Roam system, again, really focused on maintenance, right? They had a growing suburb or a growing city, a growing streetlight control system that soon grew beyond the traditional means and capabilities of maintaining that system, and the pursuit of this technology solution was very much focused on creating an improved ability to manage outages and day burners and whatnot. So notably, system controls were not installed together with LEDs. They were put up on the existing lighting system, where in LA and San Jose they were installed together as part of an LED transition. Mississauga, this is up in Canada if you're not familiar, another value proposition really kind of drove the technology consideration and deployment, and that was adaptive lighting, not again necessarily for environmental purposes, but to maintain lumen output or maintain illuminance over the life of the system, and as a strategy to save energy, right? So to not overlight the city initially as when they transitioned to LED, but dim the lights initially and then raise the power over time to maintain a uniform illumination level as the LED lighting system aged. Seattle did some pilots of lighting controls, kind of initially interested in adaptive lighting, just like San Jose was. They put up a solution in their business district. They were particularly interested in kind of the entertainment area, and maybe even adjusting light levels based on busier hours, maybe raising them up even higher at closing time, etc., to kind of explore some unique ideas. But to date, they have not found a value proposition or two or three to drive a major installation in the city. So I would say they're kind of still searching for that, those one or more propositions to drive an installation. The same is true here in Portland, where I live and work along with Bruce. A pilot was done, again, initially interested in adaptive lighting, pretty much to supplement or increase the energy savings. But again, the pilot and the ability to use or the perceived energy savings that would be delivered wasn't enough to justify a citywide installation yet, and so they're still searching also. Okay, one more slide, a few more examples. San Diego, the technology offered by General Electric was installed, driven by two interests initially in the downtown commercial business district area, the ability to tune the lights, so put up the same luminaire everywhere, but in this case post house, but maybe adjust the light level in different areas based on the exact needs of those areas. And then to follow that up by pursuing, again, adaptive lighting strategies, right, to adjust lighting over the course of the night based on one or more perceived needs or opportunities to either save energy or improve the environment for the residences. I'm going to talk a little bit now about a few non-municipal cases, right? Georgia Power is in the process of installing or actually defining installing LEDs and defining the needs for the expected accompanying control system that's going to be deployed. Initially really focused on, again, maintenance, right? Utilities, big coverage area, especially down in Georgia Power region. They have a large customer base over a large physical area. So to improve their maintenance performance and at the same time improve customer satisfaction. Again, it's still early days for them in terms of deployment, and they have not picked a single or set of technology providers yet. The state of Colorado, in particular the DOT and some of the municipal areas together have been jointly investigating the deployment of maybe a single technology solution for outdoor lighting control, driven very much right now by, again, asset management. So you kind of hear that theme over and over again, right? It's not a strong value proposition for everybody, but for many people, especially when you're addressing large physical areas, it can perhaps justify the technology all by itself. Many folks probably are aware of Boston's pursuit of technology solutions for various purposes, including security, following events there a number of years ago. And while they have looked at connected lighting systems that could address security, kind of one of the novel security needs, one of the more novel or newer value propositions, to date they have not installed a connected lighting system to address that, but rather installed just a video-only system to address their desire to improve security needs. So I would say they're also still searching. And finally, Florida Power and Light, again, if you follow the press, has been quite a bit of news about their initial deployment of network lighting or connected lighting system, not, again, as part of an LED transition. They're installing that on existing mostly HPS streetlights, but with kind of two value propositions driving that, right? One is to strengthen the AMI network that's been deployed down there for a while and improve its performance, and number two, again, common for a utility, to improve maintenance and customer satisfaction. And finally, another maybe a little bit more novel example, right? Maui has been doing some pilots and investigation and done some deployment of connected lighting system, are really driven again by the needs to address environmental concerns, again including the driven by the presence of local observatories, right, where especially on certain nights of the year desire to either have reduced outdoor lighting or if possible turn the outdoor lighting off to improve viewing conditions. So just kind of an overview again of some of the initial installations and kind of show a cross-section of the value propositions driving them. Kind of the key, I think, point I want to come across with is that even in these early days, while there are a lot of value propositions still being developed and explored, there are quite a few that, quite a bit of variation that are driving things thus far. And there's not what I would call a killer application, right? There's not a single value proposition that all by itself is really compelling to everybody, right? Even the most basic ones like asset management or potential improvement in energy savings aren't compelling for everyone. And we'll talk a little bit more about that in a few minutes, about some of the reasons why. Again, focusing on kind of those two most basic value propositions and what they are poised to offer. You know, there's the cost and impact of operational costs, both in maintenance and energy, and maybe the energy then in sustainability impact. But there's a couple of things to think about there, right? So maintenance costs are typically maybe going to be reduced by more efficiently identifying and mitigating failures, and that may affect, right, the replacement components and the labor associated to get those components out in the field. Now, energy, right? While adaptive lighting or other, techniques to adjust light output at the same time do adjust power and offer the ability to reduce energy consumption, there raises the question of, well, does that reduced energy turn into reduced cost, right? And as most people know, most outdoor lighting systems in the United States are unmetered, and so and we'll talk about a little bit more about this in a minute. In order to convert energy savings into cost savings, you need to address that. This kind of leads to what, for some people, it becomes a chicken and the egg kind of a question, right? Because to turn energy savings into cost savings, municipality in particular will need to have a tariff from the utility that accounts for that, right? And in many cases, there is no tariff, the existing tariff that would allow them to, again, turn that energy savings into cost savings. And they need that to get in place, right? But then sometimes, in order to get that put in place, the business arrangement between them and the utility, specifically who owns the lighting system, may need to be considered and may need to even transition, right? So some people, again, kind of the chicken and the egg thing as well. What do I focus on first? Getting the tariff in place, or if I don't own and maintain my own system, do I need to do that? And how do I go about doing that? Probably spend a whole webinar talking just about that, and some of that I think is covered in more detail in one of the DOE VBA decision tree resources that Crystal talked about at the beginning. But certainly monetizing again energy savings requires a new tariff for many utilities and in many regions, and that's because and that causes that can create issues, right, or needs, right, in addition or beyond just what is normally required to propose and get a new tariff accepted by the regulator, et cetera. And while the technology available right today from most providers facilitates the measurement per streetlight of the energy consumed by the streetlight, and again, the network infrastructure would allow you to collect that data. So while, again, the deployment of most solutions today would allow you to collect and obtain exact usage from your streetlights, in many, if not most cases, the existing utility infrastructure does not support accepting this metering data, right? So there's not an easy way to just create a feed or whatever, if you will, or to integrate this data coming from the municipality into the utility billing system. Or there's other challenges with regards to business practices in terms of who owns the meter, how is it characterized, et cetera, and does my regulator approve of me using this data to bill customers. There are existing standards for characterizing the accuracy of these kinds of meters. Certainly they're needed to be to allow for the use of the meters that exist on our homes and buildings. The standards that describe how to characterize those types of meters are in this country or North America, include ANSI C 12.1 and 12.20, which again discussed meter accuracy, performance levels, and test and measurement procedures, and some amount of data security for building purposes. But they're not really directly applicable to the devices, right, that are part of connected lighting systems, if you will. And the obvious big difference is those meters were designed to monitor entire, homes or entire buildings, right? Much bigger power and energy levels, and not, a 20, 30, 40 watt street light, right? So the ranges and the test procedures and whatnot aren't directly applicable. In response to that, there has been, it's been over a year now, I think, an ANSI committee formed in the C136 group, and they're working on actually two standards now, .50 and .51, very much focused on this goal, right? Tentative title for .50 is shown here, Revenue Grade Energy Measurement Device. Again, very much focused on setting accuracy performance levels and defining test and measurement procedures to verify that this type of a device, right, a controller or something that would sit out in the field as part of a connected lighting system, can accurately measure power and report energy consumption. Now, there have been some alternatives discussed in various locations in the United States, alternatives to collecting and using, again, the data that these controllers can produce in order to facilitate billing, right, and allow municipalities to turn energy savings from adaptive lighting into cost savings. And this slide just kind of attempts to graphically show the general idea. And really kind of the general idea kind of pays homage to frankly, the uncertainty around how outdoor lighting energy is billed today, right? It's done today based on an estimate of consumption, right? Based on an estimate of the power that a light source is going to consume, which actually can vary over its life, but typically a fixed number is used. And then how many hours that light source is going to be either on or off, typically based on triggering from a photocell. Again, using an estimate of dusk and dawn and how it's going to trigger that photocell for a given region in the country. So there's an average hours of use estimate that's produced. Multiply average wattage times this hours of use estimate, and that's how the tariff is established. And again, there's some uncertainty around how accurate that approach is, but nevertheless, it works. It works for everybody. It's perceived that the uncertainty and the risk associated with it is equally shared between the utility and the municipality in this case. A similar approach has been taken to bill LEDs, right? Because traditionally, our traditional lighting technologies really only came in 4, 5, 6 power levels, right? There's not an infinite number of HPS wattages, if you will. So you could have a tariff that described, okay, here's the rate for 100, 150, 200, 250 watt light source, and that's pretty much going to cover everyone's needs. But when LED came along, and this is still the case today, right, given continuous improvements in efficacy, the power or wattage of an LED that say produces an equivalent amount of light to 150 watt HPS varies quite a bit from manufacturer to manufacturer based on what chips they're using. It'll be less tomorrow than it is today. And in order to create tariffs for LEDs, utilities have had to take the same approach, right? So typically they have created some bins, if you will, where they say, okay, anything between 50 and 100 watts, right, will get billed according to this average power estimate, maybe halfway between the 50 and the 75, right, or 50 and the 100. And anything from 100 to 150 will get billed at, say, 125 watts as the average power estimate. So again, some uncertainty there in how things are being done today. So if you take those ideas and apply them to adaptive lighting, again, you kind of come up with the examples potentially shown here, that maybe one might create a tariff that would describe a model for an adaptive lighting strategy. Two of them are shown here, right? So a model that says, okay, on average, perhaps, or typically, maybe I'm going to dim my streetlights between 2 and 6 a.m. to 50%. Maybe I have a second model, Model B, or I'm calling it Adaptive Lighting Tariff 2, that says on some of my lights, I'm actually going to turn them completely off between 2 and 6 a.m. So the idea would be, well, if I came up with 2, 3, 4, I don't know how many of these models, would I kind of cover the range of what people might do, right? And might I tell people, okay, here are my models. Here is the, again, total energy consumption over the course of a year that a luminaire performing according to this model would consume, and an associated tariff. Now go tell me which of your lights are closest to, or most, most representatively going to perform according to Model A versus Model B, Model C, etc. And maybe I'd have to do some trust but verify plan to make sure if I'm a utility, that my customer actually controls the lights according to the way that they said they would when they suggested what tariff was appropriate. Or maybe I am providing the lighting control technology and solution, and I'm programming it, and I know exactly that they're doing what they say they're going to do, and that's not a concern for me. So this discussion is being talked about in some parts of the country also as an alternative to, again, figuring out how to collect and bill according to the data coming from every single streetlight. So I'm going to review a little bit here, again, the different types of tariffs that exist, again, at different utilities across the country, and again, show a couple different examples. So most often, you can kind of break up outdoor lighting tariffs into kind of these three categories. And I already talked about the predominant one, right, where there's a flat rate calculated, whether the output is fixed or variable. Again, it's calculated based on an average, typically for the whole, over the course of the year, and then divided by 12, and you get your cost, per kilowatt hour per light per month. And then there's also some utilities, again, less common, offer a fixed energy tariff that does require metering, but by a utility-owned meter, typically, right? So they don't allow a customer to put their own meter on the resource or asset, but maybe the utility would deploy one of its own meters. The cost of that would have to be accounted for, often with a per month meter charge, and then you can bill according to actual energy consumption. And then again, some utilities also offer a time of use energy consumption, even more rare, right? But again, requiring a meter. Perhaps utility or customer owned, like mostly utility owned, but since this is newer, people are maybe more thinking about both. And instead of a fixed dollars per kilowatt hour cost, there's a variable dollars per kilowatt hour cost based on the time of use in the day. So here's, again, not comprehensive at all, but some examples of these different types of tariffs being offered by different utilities in North America. Actually, here, your first example is BC Hydro up in Western Canada region. Both offers a flat but also variable output tariff. So it's calculated, but they will allow you to, as part of that calculation, not just estimate the hours, but estimate variable outputs, say, according to a calendar schedule, if you will, 50% for some amount of time, 100% the rest of it. PG&E in California offers a flat fixed output and a fixed energy tariff. SDG&E has long offered a fixed energy tariff. Excel in Colorado, right, offers a flat variable output tariff. There's some discussion there in particular about municipal versus utility meter ownership. So that's one of the places where that's going on. A little more novelly, Georgia Power has actually put into place now a time of use energy tariff that not only is available, but is the required default tariff for anyone who wants an LED. So there's that you can go look up and get the details on that. And finally, NV Energy offers a flat fixed output tariff, right? And again, I think it's not too difficult to go find details on all of these. I'm going to show you some representative text from a few of them just to get some idea of what the conditions are. So here's some specific representative text from the PG&E flat fixed output tariff. So you see there's some accounting for variable wattage and even a ballast factor. But otherwise, it assumes a fixed output from the luminaire and a fixed power level, and therefore energy consumption. Now, there are some special conditions in this tariff you see at the bottom for operating schedules other than all night, and they describe the type of adjustment that can be made. Okay, here's an example from Xcel Energy that fits the flat but variable output. There are links you see at the bottom of these slides to get more full details of the tariff. Here's some additional detail of that Xcel variable output example. So they do allow for variable kilowatt-hour use determination based on lamp type, size, ballast, lighting control device, number of lamps or groups of lamps operating together under the same control, obviously hours of operation, and the dimming schedule during the reduced wattage, or dimming schedule during dimming hours. You also see how they are implementing trust but verify, right? They may install a temporary meter or do some other periodic testing to verify that the municipality is operating the light according to how they told them they would operate it. And here are some additional details on the Georgia Power time of use energy example, right? And in particular, there's a contrast between the previous tariff for the HPS lights in terms of what the three different solutions, right? Photo control, continuous burn, part night, and the cost, and the, again, new required for LED time of use energy tariff, where you see variable rates based on hours of operation during the day, what hours the lights are operated during. So I'm going to transition now and say a few things about lighting system ownership, right, which often drives the discussion around needing a new tariff, and is more and more also becoming part of the discussion about how networked or connected lighting systems might get deployed and used. And they're, especially in cases where a municipality doesn't own and operate the system today, but wants to or feels like it needs to deploy technology that they want, whether that's LED streetlights or again, a connected lighting system. There are some very important questions that people are still kind of trying to figure out the blueprint for. And again, I think some of that's covered in the resource discussed earlier. But where do you even start? How do you start that conversation? Is there a methodology in place to go purchase the lighting system? If not, again, how do I start that conversation? In some parts of the country, this has even led to lobbying and legislation requiring that discussion to happen and that methodology to be created, which then leads only to the next question, right, which is where is the line of demarcation between the utility distribution system and the streetlight, right? Is it up at the streetlight connection? Is it at the pole? Where exactly in the pole? Often a line of demarcation needs a marking point, maybe an inline fuse or something. Different approaches have been taken in different places to define that line of demarcation. And then that maybe then only leads to the next question, which is electrical system compliance with the appropriate code, right? So many of you hopefully are familiar with the NESC and NEC codes. One more are required for compliance by utilities, and then the other required for municipal use, and typically more stringent. So sometimes then this discussion on transitioning a system, defining the line of demarcation, but then now taking some part of that system that is now transitioning to the municipality and previously met one code, well now all of a sudden needs to meet a different, more stringent code. And what does that require? Who is going to bear the burden of those upgrades, and how does that affect the overall cost and value proposition of the change that wants to get made? Kind of just a high level, you know, I don't know if I call it a roadmap, but a set of discussions that typically needs to take place here, right, is if I'm going to do this transition, well, I need an evaluation of the infrastructure that's going to transition, right? And based upon that, that evaluation can be contentious, various models people attempt to use or want to use to set that valuation. And in some cases, it just doesn't make sense, and a municipality may decide they want to abandon the asset completely and install new assets, or they do want to go buy it back. And again, then you have to address this separation, demarcation, electrical compliance questions that I mentioned previously. There's a resource here I'm showing a link to that kind of goes into kind of this diagram in quite a bit of detail, and is a interesting dialogue to read through if you're considering this. Okay, once maybe you're through those hurdles, right, and you want to go plan a deployment, here I mentioned, right, I think it's usually makes sense to think about that deployment not in, you know, as a single step, but as 3 steps, and in particular, due to who might be responsible. A big part of, I think, deployment is to consider at different points and phases, and ultimately when things are deployed, who's responsible for what, right? And you may have a different party be responsible for installation versus startup versus commissioning. And again, these are not universally held terms and demarcations, but I think conceptually they're useful to consider, right? Installation is literally just physical, electrical, mechanical mounting of devices, connecting to input voltage, wiring, etc., right? So devices have the basic necessities for operating as intended, but they're certainly not performing any functions, right? Startup is that extra set of activities required for to enable the devices to operate as intended, right? To be able to do everything the manufacturer said they can do, right? To be able to provide all the features and capabilities that are on the data sheet. So everything's available to the user, right? And here you're dealing with setting up the communication network and provisioning and addressing any spectrum or interference issues, kind of making those connections I mentioned at the beginning, you know, between the field device network and the network infrastructure and the backhaul, in the central management system, etc. So everything the technology can do all it's intended to do, but it's still not customized yet, right? And here I'm using the word commissioning to describe the stage or set of activities where system functions and capabilities are configured exactly according to user needs, right? So here's where you're doing grouping and scheduling, maybe configuring sensor algorithms, implementing adaptive lighting schemes, etc. So I think these things go in sequence. You can't skip steps, and often you may want to consider different parties to perform and be responsible for the activities under each phase. Okay, another thing that needs to be considered again, again, this is not exhaustive at all, but kind of some very other high-level things when planning a procurement is what luminaire integration plan or strategy do I want to pursue, and what options are available to me from different technology providers. So kind of 4 broad categories here, right? Something installing a device external to the luminaire, but maybe where I only want to be able to turn the luminaire on and off. And here I can deploy a ANSI C136.10 or .41. Hopefully everyone's familiar with these now. A compliant device that can plug into a receptacle available on the luminaire. However, if I want to do dimming or adjust the light output, I need to definitely facilitate the ability of that external device to send a control signal into the luminaire. Historically, a number of manufacturers have enabled that with the traditional 3-prong receptacle by requiring you to install something else, right? Drill a hole and send some wires through the luminaire, maybe creating a power line carrier signal and then putting a decoder inside the luminaire to read that signal, or sending a short wireless signal literally again from the external control into the luminaire. But more and more now, with the broad availability of ANSI C136.41 compliant luminaires, right, and manufacturers offering that 5 to 7-prong plug on the external controller, that is the simplest and most efficient way to provide that dimming signal into the luminaire. Now, some manufacturers from the beginning and today also offer solutions to install a controller internal to the luminaire, which has a number of advantages, potentially including lower cost, but definitely raises a new kind of question, which is who's going to do that installation and who's responsible for the end performance, right? If something doesn't work, who's responsible? Was it the luminaire maker? Was it the control manufacturer? Is it a third party who installed the one into the other, etc.? We have seen some issues in the past where that internally mounted device maybe was mounted too close to, or even in some cases right on top of the LED driver, and resulting in a rise in heat or thermal temperature of both of those devices, potentially degrading performance, etc. And in the future, not any of these solutions that I'm aware of yet in the United States, but certainly a number of manufacturers are building and even deploying in other parts of the world solutions where the control technology is just integral to the luminaire, right? It's integrated into the driver. It's kind of like the way people address dimming today. It's there whether you want it or not. Maybe you're going to have to pay extra to have that feature turned on, but it's just part of the capability offered by the luminaire. So kind of some graphical, again, examples of those 3 different types. Again, external mounted controller. You see an example on the top of, looks very much like a traditional photosol, maybe a little bit bigger. In the lower left-hand corner, you see an example of an integral solution, right, where only the antenna is exposed. And again, soon, at some point, maybe even this year, we'll see solutions on the market where the control technology is just built into the luminaire. Some lessons learned, I guess, from some of those various approaches, some of these pilot projects. In some cases, the location of that externally mounted antenna has proven to not be ideal, or the durability of that antenna. You see kind of an example here of an antenna that has suffered some deformation as part of its transit, if you will, and may not be performing ideally. There isn't a standard yet that describes maybe where to put an antenna, remote antenna mount on a luminaire, or define a connector, right, by which a remote antenna might be screwed in to a luminaire, and or define characteristics of an antenna, etc., such that maybe the antenna could literally be mounted out in the field as part of the luminaire installation, instead of what is often the case, having to be done somewhere else in a lab, in a factory, etc. And then you got to deal with, again, maintaining the durability issues and maintaining the physical viability of that antenna during transit, etc. Another consideration, right, that sometimes actually in some cases has gotten overlooked initially, which is, do you know the various input voltages that are serving or power to your existing system, and does the technology provider offer controllers for all those voltages, right? So here is just an example. This now is maybe a year old of a survey done of different vendors showing you the various input voltage options of their connected lighting solutions. And you see not everybody is offering every solution, right? Some people offer only fixed voltage controllers. They only work at 120 or 240 or whatnot. A number of folks offer universals that offer, say, work between 120 and 277. And then in particular, the high voltage offerings maybe are only offered by a few people here and there. Certainly some of this maybe has changed over time, but it's definitely something to investigate. Now, of course, there are ways to deal with this, right? You can install a internal to the luminaire transformer to bring higher voltage feeds down to the level needed by the controller. But then again, one more thing that has to get mounted in the luminaire and selected, and who's responsible if it doesn't work, et cetera, et cetera. Lighting control protocol. So I already mentioned, right, the decision of, am I just going to want to turn my light source on or off, or am I going to want to dim so I can enable adaptive lighting and pursue those energy savings and enjoy the fun of trying to get those savings turned into dollars, etc. Well, there are multiple ways to create that control signal, especially from an externally mounted device, and send that control signal into the luminaire and adjust the light level. The two predominant approaches available in luminaires today are 0 to 10 volt and dolly. Some very important high-level differences between the two. Certainly 0 to 10 volt is much more predominant, much simpler. It, however, only allows for one-way analog communication with the driver or ballast, so you cannot read any information back from the driver or ballast or luminaire, right? You can only send a single communication signal, if you will, into the luminaire that is going to be interpreted as a dimming or reduced lighting level. But that protocol does not allow you to specifically set, or to set a specific power light level. Again, if you aren't familiar, you can go read or ask a question about it later, but that protocol really just describes, okay, above a certain control signal level, you should be at full output. Below a certain level, you should be at minimum output, whatever that is, and in between, you do whatever the heck you want. So it requires extra configuration and steps to allow someone to specifically say, hey, I want to be at 50% power, or I want to be at 50% relative light. The dolly protocol is two-way. It's digital communication, so you can both pull information back and send that dimming control signal. You can set a light level because that relationship between control signal and light level is defined by the protocol. And you can theoretically extract information from the luminaire or from the driver or ballast, such as maybe make and model and power profile, etc., or maybe even dynamically changing characteristics like temperature. And in fact, there are some, in particular, utilities who are pursuing this approach to, again, contribute to their ability to better maintain their lighting system and deliver value and satisfaction to their customers. Here's kind of an example of, again, how that the relationship between control signal and light output may vary between two different luminaires, and how that relationship is defined for the dolly protocol. Now, the two different plots here you're seeing are for measured light versus perceived light. Important to know the difference there. But it is also important to know that just because a luminaire says it complies with the dolly protocol does not mean that that luminaire goes down to a minimum dimmed level, right? So while you maybe are able to specify relative light output, you can only specify a level down to where the luminaire goes, right? So dolly source or luminaire A may go all the way down to 10%, but source B may only go to 20%. And if you send a control signal asking for something less, you're just going to get the bottom floor that it enables. Okay, and wrapping up, a few more again, other things to consider, including location commissioning, right? So how are you going to record where this controller is being installed, and where the pole and luminaire that it's being installed on is, right? And the technology solutions available in the market vary from having no capability at all to assigning the controller to a location that exists already in a database. So you're doing that solely at the, in your back office at the with the central management system. A very common approach is you can capture that information out in the field, but you need to use some field commissioning device, some kind of PDA tablet-looking device that has a GPS inside of it. You maybe scan the barcode of the controller you're installing, you press a button, you wait for that device to capture the GPS location. Maybe it takes 10 seconds, 20 seconds, a minute, and then it attaches those two things together, sends it over the communication network, and the two are associated with each other. The most sophisticated approach, but obviously the most expensive too, there are a number of solutions on the market where each controller has a GPS receiver in it. So from an installation standpoint, you can just go install the controller and move on to the next one, and in the meantime, that device will lock into a GPS signal, however long it takes, and automatically report it back, and thereby log the location. Some pretty straightforward, if you will, lessons learned or comparing and contrast of those approaches, right? And a lot of them revolve around the use of GPS, and I kind of already alluded to them, right? If you're going to use that field device, how long does it take to get an accurate location reading before you can move on to install the next device? And there's a trade-off there in accuracy. You wait 10 seconds, you get signal from 2 satellites, you're so accurate. You wait longer, you get signal from more satellites, you're more accurate. Versus, you install, you purchase something where the GPS is already in the controller, but you're paying more, 10, maybe 20% more per controller nodes to have that capability. And kind of making that decision, I think from what we've seen, really kind of comes down to the municipality utility having a good idea of how often might they be moving these controllers, right, for one reason or the other, and how many do they want to install, right? There's definitely a big difference between wanting to install 1,000 of these total, where maybe waiting a little bit longer per controller is not a big deal, to maybe being someone like the city of Los Angeles that wants to install 1,000 of these a week or 2,000 a week, right? So I think size matters there. Okay, looking to the future again, I've kind of already talked about adaptive lighting from an energy savings, standpoint, and the issue of maybe turning that energy savings into cost savings and needing a tariff to account for that. But there's the other side of adaptive lighting, which is, well, if I'm going to do this, how do I know what light level to adapt to or to set my system to, and what's appropriate and safe and whatnot? And here I really just want to alert you to a relatively new publication offered by the FHWA, including that describes design criteria for adaptive roadway lighting. There's also a little bit of discussion about non-energy benefits and whatnot in there. Certainly, there are a whole host of other value propositions that are starting to be offered or being offered by this technology, and people I think, are still very much in the early days of figuring out how to qualify or quantify them and consider them in the cost-benefit analysis, if you will. And just a small set of those are shown here, right? Again, enabling your lighting system to become a data collection platform and leveraging emerging, big data and analytics and cloud computing capabilities to turn that data into knowledge, if you will, or information. I already also alluded to, using the system to provide security benefits or even public relation benefits through the use of integral displays or even speakers. A little bit here about, again, that first value proposition I mentioned, implementing adaptive lighting according to some guidance, if you will, right? And so that FHWA document does talk about how to adapt to a number of varying conditions, right? You see a list of them in the left-hand column here. I've highlighted one, right, where maybe I would adapt to traffic volume, right? And here are some categorization. There's 3 categories suggested here: high, medium, low, and then 3 kind of traffic levels or 3 criteria that would lead to a weighting value. I'm not going to go into how these weighting values are used, but there's an equation provided if you're going to implement many or multiple of these strategies where you add the weighting values together to determine what light level is appropriate. But at the end of the day, again, this kind of raises another question. Okay, I want to implement adaptive lighting. I want to save energy. I maybe have a tariff that will allow me to turn that into cost savings. I understand, I believe in someone's guidance, or I want to follow someone's guidance on what I should adapt to, and what metric or criteria I'm going to use to adapt to level A, B, or C. But then I have another question, right? And a number of cities are really kind of at this stage, I see now, where, well, how do I know that my criteria, in this case, traffic volume, has transitioned from 750 to 1,500 to more than 1,500 vehicles hourly per lane, right? Certainly, many cities in some locations have traffic sensors that are enable that kind of data collection, but they're certainly not available everywhere. So what do I do if I want to enable this strategy broadly, right? Do I come up with average use cases? Can I interpolate between where I do have that data available? Can I associate or correlate the other types of data that I have, such as mass transit schedules, etc.? Quite a bit of thought going on and discussion, again, around how do I collect the data that I might need to enable the adaptive lighting strategy that I want to deploy. Here's an example of how one municipality went about that. Not everyone's going to be able to do this, but they hired a consultant and then collected data, right, in some strategic locations, and then they kind of assigned or categorize the rest of the city as complying with one or more of these locations. So they're going to, base their calculations, if you will, traffic calculations, based on the data collected, in the representative areas. So with that, I'm going to conclude and open it up for questions. I'll note here that there's another DOE resource that's been available for a while in its second version, and we may release yet another version sometime in the next year or two, but this is a model specification for networked outdoor lighting control systems. So it kind of goes into detail on many of the variations you see in commercially available technology offerings. It's a template, right? So it's not a fixed specification where you might go hand it to a technology provider and say, can you meet this or not? But rather, it's a template that guides you through thinking about, again, many of the ways the systems or the offerings vary, and offer you the opportunity to select or not certain requirements based on your needs. So there's a link at the bottom there provided for how to go download that resource. So with that, I'll close and thank everyone for their attention, and see if we have any questions.
Thanks, Michael. Very, very informative, and it's obvious there's a lot to be learned with these systems. So it's a good job sort of turning on the fire hose and drenching everybody here with this. I have a few sort of crystal ball questions for you, your favorite type. When given that what the barriers and what is going on out in the industry right now, the things that people are trying to, the initiatives and so on that are going, what do you think the actual tipping point is likely to occur in terms of these systems heading for mainstream sort of application?
Well, I don't think there's one, but I think that there are a couple that are coming, right? And they're both kind of momentum types of things, right? Where once they get rolling, I think more will happen. So certainly, one is cost coming down, right? So the more interest, the more deployment, the more competition, the more manufacturers actually believe in that there is going to be a big market here, the more we see interoperability become available. That will allow manufacturers, as I mentioned, more of them to pursue integral options, right? Where most of the additional technology required to do this is just going to be integral to the luminaire. That all by itself can reduce costs tremendously, right? The additional cost to deliver these features and capabilities. I've heard some people say it's would reduce costs 50%, 75% of where they are today for the same features and capability. So as the cost comes down, and frankly, related to the cost is, new business models become more, I should say, prevalent. They're already out there, but become more established, right? Everything from, like I said, a manufacturer just deciding, well, I'm going to sell all my luminaires with this technology built in, and you'll just pay extra today, tomorrow, or 3 years down the road to turn it on, to lighting as a service and whatnot. So I think improving the cost, reducing the cost is one end of it. And the other end of it is kind of the other half of the equation, if you will. Everyone's looking at cost to value, right? So reducing cost improves the odds. Increasing the value is the other half. And again, there's some activity, right, where different cities or users are venturing out there and saying, well, I'm going to be the guinea pig to really look at some new value proposition, right? Whether it's parking lot management, if you will, right, or collecting environmental data to get a handle on and try to improve the air quality in the city, right? As significant people really evaluate and vet and in some way qualitatively or maybe ideally quantitatively can wrap their heads around the benefits of that value proposition and communicate that to other people. That's something that we are definitely trying to help happen, right? Or role we're trying to play, right? As people learn those lessons, we want to help communicate them out to the broader set of users, if you will. So as that starts to happen, I think you'll see more interest also.
So do you think this is going to be, you emphasize cost quite a bit in that answer. Do you think it's more cost-driven than capability-driven? You don't think like there's going to be a killer app that everybody will say, okay, that's it. It's we have to pay more for this, but the value proposition basically is so high on this that that's what's going to drive it.
I mean,
more cost-driven. Go ahead.
Yeah. Well, I'm crystal ball. I don't really have a crystal ball, so you're just guessing. I don't see a killer app now. I don't see a killer app emerging later. I think there's just going to be a growing number of application or value propositions or application, and it'll be more likely that people will be able to quickly, or in some efficient way realize, yeah, these 3 work for me, or these 4, or whatever, right? So it'll be matching a growing set of value propositions, a growing set of verified, qualified, quantified value propositions to their needs, right? And I think there's also just general education around that too, right? What is available? What can these things really do or not do? Even comes first, and then who has looked at something and proven them out, and then yes, A, B, or C, are gonna make this compelling to me. And I think we've seen in other areas sometimes for some users that equation always requires cost, right? I'm always considering the benefits in relation to the cost. But for some cases, users, there may be benefits that are so compelling that cost becomes more in the background, right? I have this problem, I have to solve it, right? And I don't know of another way to solve it, or I know, a non-technology solution way to solve this is going to be way more expensive, right? Whether it's, I don't know, around, redoing traffic lanes, right, or physical infrastructure or whatnot. And in some cases, some of the value propositions we already see, right, are potential revenue producers, right? So that maybe doesn't change the the initial cost, but the ongoing cost, right, can be dramatically reduced or maybe even flip around if the data, say, for example, collected by a network or system here is capable of producing revenue. Not a lot of examples of that right now, but that, you know, that's potentially coming in the future.
What you said sort of parallels sort of the implementation of LEDs in street lighting applications. That is, they've been, you know, in some locations, people have been willing to maybe spend more to get those out there because they offered, I guess, capabilities or features that they were interested in. So do you think control systems is likely to sort of parallel that in terms of its rate of application, or do you think there's going to be a much more rapid adoption rate once we sort of cross that, whatever that tipping point is?
Well, now I don't know. Now you're really out there in the crystal ball, I think.
Just wait, I got another one for you.
Well, I think you know, again, I think when you really start to consider that the opportunity to turn your lighting system into a resource that does more than produce light, and again, I'm talking about collecting data, that starts to become interesting and relevant to say in a city, if you will, or even to a municipality, right, to a greater cross-section of again, the municipality or the utility, right? It's not just about changing the you know, economics or the equation for lighting, right? It starts to create opportunities to, again, improve quality of life, improve, you know, air quality, generate you know, revenue, if you will. And so that's the direction I think connected lighting is going in general, right? It's not just about lighting, it's about things beyond producing light. And as that, there's a lot of energy, I do think, building around that. Again, turning lighting systems into data collection platforms and leveraging that data for all sorts of uses that, you know, maybe the killer apps are out there that no one has just thought of today. The better analogy there, instead of LED, is, you know, your mobile devices or computing devices, right? Once you enable that capability, you create a platform for ideas and imagination to really flourish, and all sorts of things maybe come out of that. So if and when that happens, then I think things will go faster than they did or are going with LED. Until that happens, probably go slower.
Do you think we'll get to the point ever where people, it's kind of like your smartphone, which has all these capabilities, it has a camera, it has all these things in it, and then you've got the people out writing apps basically for the smartphone. Do you think we'll ever get to that point where people are writing apps that maybe not, obviously not to control the streetlights, but maybe to use data that's being generated from them, using different systems that are, you know, data streams that are available as a result of this? For, you know, I'm thinking of things like in Portland where people are accessing the bus line information, for example, and now you can get an app that's been privately developed that basically tells you when the bus is going to arrive at the next stop and things like that. Do you think we'll ever get to that kind of point with these systems?
It's a real guess, but I would guess yes, right? Because, like I said, I think there's a lot of energy building around this opportunity. I think more and more people are thinking about the possibilities already. More and more technology providers are of all types, right? We're not just talking lighting companies, but, you know, IT companies, you know, Cisco's and Intel's and Microsoft's, again, are thinking about the opportunity here of collecting and leveraging data out in the physical environment from lighting systems where there's already a lot of momentum being created to retrofit existing lighting devices with a new device, right, driven just by the energy savings of LED. So there's this opportunity, well, if I'm going to go do that anyhow, what if I put in a device that, again, has these other features and capabilities? How much more does that going to cost? How much more does that enable? How many other mechanisms can we create to get more people to do that? I think there's enough energy and opportunity and need for that to happen, even just to continue supporting technology development out in the industry, right? And literally technology GDP, literally, that if I had to guess, it's just a guess. If I had to guess will it happen, I would guess that it will.
You mentioned Cisco and some of the other majors. Do you think that we will continue to see smaller players in this space, or is it probably going to be the larger companies that will move in, and maybe even companies like Google or somebody else like that getting involved?
I think just like historically is true, it's a cross section, right? When this is a big, I think, opportunity that opens the door for lots of people to think about a role for themselves, whether it's a big established person who maybe has reached a plateau on growth and revenue and looking for a new way to continue growing, versus a new guy, right? Who's got a neat idea or a neat piece of technology, looking to, gain a foothold at the bottom, at the beginning of an avalanche, if you will. But then that has a life of its own often anyhow, right? Only a small number of those small guys can grow to become big guys. The rest of them either don't survive or get acquired by somebody else, and that's happened 100 other times before, and might happen here too.
Okay. Yeah, I have a couple of very specific questions here. Let me modify this one because I know the answer is yes, the first answer. The question is, since LEDs are instant on devices, has anyone tested control by motion sensors? Let me modify that a little bit. Do you know of any street lighting applications where anyone is using, there's definitely installations in parking garages and lots of other places where LED luminaires are being controlled by motion sensors, but do you know of any actual street lighting applications where that's being used?
So I know of a number of people who have piloted that, right? And so, in brief, right, by and large, people are looking at leveraging previously, developed technology, right? Passive infrared, maybe ultrasonic, right? That sensor technology to do the actuation. And as you might imagine, that works outdoors. That works best in environments that look more like where the technology has historically been successful, right? Where it looks more like indoor installations. So you mentioned one, right? It works best in garages, and I think is being deployed quite a bit in garages. It doesn't quite work as well in parking lots and pedestrian areas, by and large, because of where we're going to mount that sensor, right? If you're mounting it, if it's integrated into the street light, it's at a much higher up, and you need a much bigger coverage range than, again, what a lot of initial offerings can do, or what even the technology is capable of. But are there people who have done it? Sure, right? There are pedestrian, especially I know post-op installations where they're leveraging that traditional passive infrared technology to do adaptation, and it's a subjective evaluation to comment on how well it works or doesn't work. There are a number of folks also working on what I would call new technology, right? So new types of sensors or sensor technology that are more suited to the outdoor environments, right? And more suited to the other applications, including even street lighting, right? And that's those are using, again, broadly microwave and video-based technologies. I've seen some of them. Some of them work quite well. I think the bigger challenge there is how do you get the cost down to the point where you might consider, putting lots of them out there, not just one here or one there where there's a really critical, or high value need. So I would say that that's coming. And then there's actually other ideas around how you would detect the presence of people or effectively people, right? Instead of, again, using an active or a sensor that is outward looking, maybe I would, one easy to think about example is detect the proximity of cell phones, right? Which are more and more on people or in cars and whatnot, and there are various approaches to be able to detect fairly accurately how many of those are in a certain vicinity, and even how far they are away from a particular location, right? So that. What
about Wi-Fi? That's the next question I had. Is anyone offering Wi-Fi via modulation on the LED light beam? So they're essentially talking about Wi-Fi. Do you know of anybody using that?
Not outdoors. I don't know. People are doing that indoors. So you got to be careful there, right? So you can use light modulation both to kind of replicate or serve the needs of Wi-Fi for like high bandwidth, right, high data rate needs, Or in simpler incarnations, you can do it to provide low bandwidth or low data rate needs, right? Say maybe this is what's being done, right? Maybe to determine where someone is in a shopping mall, and based on where they are, send them a coupon, right, to their cell phone. That's certainly being done in both ways, more for the location and low data rate needs indoors. Lots of people have that solution, and there's a number of installations, growing number of installations that have it. I'm not aware of it being done outdoors yet.
Okay. Well, thanks. We're out of time here. Thanks again, Michael, for a very informative presentation. To the people still on the line, we're very interested in getting your opinion of the material that was presented today, and maybe what related topics you might like to hear more about in the future if we decided to do another one of these. So we're planning to follow this up with just a brief couple of questions via email, and would appreciate your feedback on this. So thank you for participating in today's webcast that's brought to you by U.S. Department of Energy's Better Buildings Challenge. We hope this was helpful in bringing you a little bit more up to speed on connected lighting systems, and that you'll join us for other webinars in the future. So you may all now disconnect, and thanks again.